Hello folks, welcome to GWizard University. Today we're going to give you a quick overview of how to use the feeds and speeds calculator for milling machines. So basically you want to use the calculator going left to right and top to bottom. So I'm just going to walk you through what all these different things do in that order. I'm going to make one little exception to that, which is I want to show you this is how GWizard will come up when you very first install it. And this is in what we call simplify mode. You can switch between simplify and advanced with this button right here. You can see what it does is it just gives you a whole lot more information as well as some more advanced options here in this middle area. So we're going to leave it running in advanced mode just so you can see what the impact is on everything, and we can talk about all these additional controls and so forth. Okay, so going left to right, top to bottom, first thing you want to do is select what machine you want to calculate feeds and speeds for. You can go to the Setup tab to create additional machine profiles as needed, and it comes with a bunch of built-in profiles. Today we're just going to run what we call our generic VMC profile. This also displays for you any adjustments you've baked into the machine profile for the surface speed or the chip load. So for example, you could set up a machine profile that always runs at about 90% of what GWizard would recommend in order to extend tool life. Materials. Usually you'll just come in here and select from one or the other of our families of materials. Sometimes you want to get a little bit more detailed, or maybe you're just trying to figure out which family you're looking for. So in that case, use the More button. And you get a bunch of additional tools here to help you with either finding a particular alloy and condition, understanding what family you're looking for, so on and so forth. So for example, let's say I wanted to, I've got some kind of foam board that I'm using for modeling or sign making purposes, and I want to track that down. I put in foam and I search, and composite foam board is right here, and we see this is from the soft plastics family. So use the material browser with the More button in order to track down a little more detail about what material you're using. Tools. GWizard supports a ton of different types of tooling, different cutter types that are listed here. The most common ones, we've blown out all the different varieties right here at the top level. Some that you use less often, we may put the high-speed steel versus carbide option off on a little sub-menu. But you can see we have a tremendous number of different cutters available here. And I want to talk just briefly about some of the meanings on the end mills. You know, if you're in doubt about what the cutter is, choose end mill, because we'll show you in a second how to use the geometry button to dial up some special cutters based on end mills. So you've got high-speed steel, HP or high-performance high-speed steel, carbide, high-performance carbide, and TIALN coated carbide. And people always want to know, well, what's the HP all about? HP is if you have a coating or a premium geometry on your tool, choose HP and you get a little bit of kick up on the performance there. The exception of that is TIALN as a coating has so much more capability than your average HP coating that it gets its own category all by itself. So select your tool and you're ready to go on to the next step. And we're going to talk about a number of the more advanced features in later videos, so we won't cover the tool crib just yet. Okay, next row is all about more details on the tool. So for example, the tool's diameter. This is a 1/2-inch tool. You can select the diameter from ready-made diameter sizes here if you wish. If you're trying to figure out what the nearest diameter is to some dimension or something. Tell us how many flutes you're going to use on your cutter. Geometry is a really useful option to be able to invoke because it gives you access to tooling that's related to end mills but has a little bit different geometry. For example, a ball nose cutter for 3D profiling is available. You've got a number of different dimensions you can fine tune here. Some are grayed out. just ignore those. They're not used in the calculations. They're intended to be used for features later on that we haven't introduced yet. But we wanted to go ahead and have them be present in the diagram so that when we get those new features, we can just enable them. Anyway, fill out your geometry if you need to, and you only need to if you're using something other than a normal end mill. But for example, if you got a bullnose end mill that's got a corner radius, you can fill that out right here. The next one we have is stick out. Stick out, and you can see if I hover here, I get a little pop-up tool tip. Stick out is the distance from the tool holder to the tool tip. And the longer it is, the easier it is for your tool to have deflection. And we'll be doing a whole video to talk about deflection, but for now, just consider that too much deflection is a bad thing. And you'll know you've got too much because this little deflection calculation turns red at that point. So stick out. The other thing I want to say about stick out is it's measured differently on micro cutters. Here's a typical micro cutter. And we measure normally from wherever the tool goes into, say that you're using a collet, where it goes into the collet to the tip. But in this case with a micro tool, we only measure to here because this tapered shank is so much bigger than the fluted area that it just overwhelms. It's so strong that this is not worth worrying about this distance here versus this distance here. So just measure from tip to where this taper begins. If you're using micro tooling. Okay, that is stick out. There's also an option if you're using what a lot of people refer to as a corncob rougher. These are the end mills that have the serrated cutting edges, and they're capable of going a little faster and avoiding chatter because they break up the chips with those serrations into smaller chips. So they're really pretty neat, pretty useful. The mini calcs, again, we'll have other videos to talk about the mini calculators, their special purpose, and we just want to stick to the basics here. Okay, then we have what we call the cut conditions, which largely consist of the depth and the width. And here's how to think about the depth. The depth is the length of your flutes that are actually doing any real cutting. So as you step down, for example, in a pocket, you may go down in 3 steps until your cutter is, let's say an inch deep. But each step, you're only going to cut a third of an inch. And so what you put on cut depth is not 1 inch, you put the 1/3 of an inch. Axial engagement is a percentage value, and it tells you how much of your cut depth in diameters you're doing. So, 1/2 inch tool, 1/2 inch deep is 100% axial engagement. We put it here because a lot of the tooling catalogs refer to axial or radial engagement. So cut width is, if you view the end mill from above, it's circular. How much of that circle is embedded in the cut making chips? And if it's a full slot, it's the entire diameter, and you click this slot button to get a full slot. And that's 100% radial engagement. Smaller, maybe you're only doing 0.1. Cut width is also referred to by a lot of people as your step over. Okay? Once you've entered that much, you're ready to start getting some results. GWizard will tell you the RPMs and the feed rate. And here's a plunge feed rate. That's how fast you can vertically descend the cutter to get it into the cut. Very important not to go at full feed rate straight down into the cut. Next one is an option that gives you a little extra performance if your fixturing and machine are above average in rigidity. I mean, if you've got a big horizontal milling machine compared to a similar vertical milling machine, typically the horizontal is much more rigid, and so you can select a more rigid setup here and get a little extra performance for your trouble. We already talked about the simplified versus the advanced view. Now down here you get a bunch of data about your tooling, and we'll talk about how to override this information in future. But suffice to say, for example, you could come along and say, well, my RPM limit is really only 5,000 RPM on this machine, and it will then limit your RPMs to 5,000. And the padlock is telling you that it's no longer considering what it thought was the right answer. It's taking your answer instead, and you just click the padlock to make it go away. So lots of overrides are available for you to customize things, and we'll talk about overrides in another video. I'm trying to keep these videos short. Likewise, the high-speed machining I want to talk about in another video. Two things I do want to finish up with, though. One is our tips area, and the other is our Tortoise Hare slider. So let's start on the tips. Tips are pretty cool. You find all of these little hints and techniques in tooling catalogs, and you wonder how the heck you're ever going to remember them. And what we try to do is build those into GWizard. So for example, it says here that for this cut you should use conventional milling. That's kind of interesting. Most CNCers get trained to where they always use climb milling, but it turns out there are certain geometries that come into play depending on your cut width where it's better to use conventional. Now if I back off, right, it comes back. I selected a much less cut width, much smaller engagement, and now I'm being told to use climb milling. Another tip that comes along tells me what are the best coatings to use with the material I've selected, and so for aluminum it suggests TIN or TIALN. So lots of good stuff coming in on the tips area. Now let's talk about the Tortoise Hare. The Tortoise Hare does a couple of things. One, it lets you regulate how aggressive you are. But two, it's a balance between material removal rates or roughing and surface finish and tool life or finishing. So you note the little area here says rough, right? This is a lighter roughing. This is the beginning of a finish. And all the way to the left is a special setting called fine finishing, which is trying to pick the slowest we can go without causing the tool to rub. Now, experienced machinists know that if you go too slowly on these things, your tool will eventually rub. So, for example, if I set the feed rate way, way low, as a beginner, I may think that I'm babying this cutter, but in fact, the chip load's too low. This may cause rubbing, and that will burn up a tool really quickly because when it starts to rub, it quits cutting the chips cleanly, starts to generate a lot of heat, and that's just very bad for your tooling. So keep an eye out for those kind of warnings, and you saw how it turned red and so forth to really let you know there was a problem. Likewise, if I get a really long stick out, I just want to show you another warning that it'll give. 3 inches of stick out, a ½ inch cut produces deflection. I've got too much deflection here. Now, anytime you see red, you want to make sure you really understand what's going on there, or you want to try to get rid of the red. I mean, there's cases where you could choose to just go ahead and put up with that much deflection. And if you know what you're doing, that's great, go for it. But if you don't, you're going to want to look for another way to do things. And, for example, you might back off on this cut depth until you can get by without any deflection. All right, so those are the basics of using feeds and speeds for a milling machine. We'll get to drilling down into some of the more advanced details in other videos. And thanks very much for visiting GWizard University.